All right. I think we are live. Yeah, seems to be good. I might get up in a couple of minutes and fetch something to drink because I forgot that. And I will wait a few minutes for people to arrive and get comfy. Other than that, I think everything is here. Let's see if the sound seems to be good, but I think it is. I see at least something here. Anyone in the chat yet? I don't think so. So yeah, I'm gonna fetch something to drink. We'll be back in a minute, and maybe somebody will be here. There we are. Well, not quite sure. Otherwise, I'm making this stream just for myself. I'm gonna check if everything is set up correctly once more. Where is the link? Here we are. Try to... Hi, Roger B. I think there's something wrong. Oh no, it works. Okay, cool. I think we're live. Gonna take a sip of the alcohol-free Warsteiner beer. That seems good. So I'm gonna start talking and rambling a bit before doing the actual operation here. Today we Farbe 08 joined. Hello. Today we're working on one of the famous Commodore drives. This is a Commodore 1541-2, which is the later version from around 1987, and this seems to be an early version perhaps, because all the date codes on the chips are from late 87. So it's not a super young variant, basically. I'm not sure about the PCB revisions. This is already very much shrunk down from what the original 1541 had. I have one up here, but you can't see that. The 1541 was basically huge because it also had an internal transformer and power supply. This one has an external power supply, which I have lying here for tests later. On the back you have the usual stuff. You have the power input here, the IEEE interface, or IC. It's not IEEE because it's serial instead of parallel, and the serial is just where you plug in multiple devices like a printer or another disk drive. And there are two dip switches to set the device number, similar to SCSI. The IEC bus or the IEEE bus has device numbers to address the device in question. And for those who didn't know or don't know, the 1541 and the 1412, it's all basically the same. Nothing much changed in between except for greater integration, but even that is not super highly integrated here, except for this gate array chip, I think. So the idea is that the 1541 and 1541-2 is basically a computer on its own, and comparably in computational power to the C64, the VIC-20 and the PAD, because it uses the very same CPU, the 6502. Well, the C64 used the 6510, but it's just the same thing with a slightly different pinout. Then there are two versatile interface adapters, 6522, this gate array chip, which manages the access to all the chips and the bus, a ROM chip. This is a combined ROM chip. I think in the older 1541 it's like 2 or 3, I think 2 ROM chips. Then we have the SRAM, like 2 kilobytes of RAM, which is of course the limitation here, so you can't run arbitrary programs, but you can run fast loaders, speed loaders, stuff like that inside here. A little bit of glue logic. And this all works on this particular device. But I got this from a forum member of the Forum 64, and he said, yeah, my 1541 stopped working, it doesn't read or write anything. And looking at it, you can already tell from the front that this is a Mitsumi drive. There's also a Chinon-based drive, which has a slightly different bezel here. And looking inside, you will find this mechanism, which is a 5¼ inch floppy disk drive mechanism. Pretty simple stuff. There is a rather large but flat stepper motor, which moves the head assembly around, basically like this, back and forth to read and write to the disk. Then there's this 12-volt servo motor, which drives this flywheel, which turns the diskette, basically. There's a little bit of electronics going on here. I think the BA6301 is an amplifier or something, I forgot. And there's a pot for adjusting the drive speed. If you turn that, the RPMs will change and you need to get to 300 RPMs. And that's more or less it. It's a very simple drive, and Mitsumi or Neutronics produced a lot of mechanisms for Commodore, like probably millions. They were not the only source, and they lasted for quite a bunch of years. But it turns out that this little thing here, this black thingy, and especially the white thing below there with the black stripe, this is the actual read-write head, because these are single-sided drives. The reason for the famous flippy disk, where you have the disk notcher, which lets you cut out one of the corners of the floppy disk to make it a flippy disk. So you can use the second side as well on the Commodore disk drives. So this thing here, this white thing here, and at the top it's only a felt pad to not destroy the diskette. This breaks, this white thing. You can't see it, but looking at the underside, there's a little PCB, and under the PCB on the other side there is embedded into resin a very, very tiny, what do you call it? Coil, basically. A read-write coil with multiple tabs for reading, writing and erasing. And the cables there, they break over the decades, especially with these Mitsumi drives. And that's a bit annoying, because you can't get them new anymore, except you can. So in this package here is a new old stock read-write head. You can already see a similar assembly that can be used here, I think. If not, then we're out of luck. But I think that's exactly the same thing from the looks of it. Yeah, it looks pretty neat. And we will try to replace that. It's a bit fiddly, and you need to calibrate everything in the end. Yeah, but that's that. And how do I know that the head is broken? Well, for that, we take my brand new multimeter, and we take this wire here, which has or this plug, which has 4 wires, a black one, blue, red, and yellow. And these are the different tabs of the coil. And let's just take, for example, the connection between the black and the blue, and putting my probe in there will reveal something, hopefully, if I can get it to make contact. 13 ohms. That's totally correct for such a read-write head. And black and yellow gives us 13.7. This is also perfect. And black and red gives us nothing, open line, which means there is a break in the coil, and that's annoying because you can't fix that, or at least I can't. If you Google, there's a post on the Forum 64 where someone actually dug out the coil and repaired it. There's a couple of people who dug it out and didn't repair it. They failed to do it because it's super tiny. You need very special equipment, very thin wire. But there's one guy who managed to do it because he just wanted to see if it can be done, and it can be done. But it's super, super hard. So, and of course, new heads haven't been in production for like probably 30 years or so, at least more than 20 years, which is annoying. This also doesn't look super great because the cables get very squished, so things get stuck here. And the interesting part will be now to how to disassemble this. Feel free to put stuff in the chat. I'm reading it in between. Ask questions, ask away. We need to be a little bit careful because there's stuff that can basically just jump away. Because there's, for example, one spring here. So the mechanism works like this. The stepper motor drives this metal wheel here. And this wheel has, I think, yeah, it has a screw here, glued with Loctite. I don't have Loctite per se, but I have conformal coating for PCBs. I might use that plus some ultraviolet light later. But for testing it should be fine without. So there's a screw holding a metal band in place, which drives the actual sled with the read-write head. So first thing that I'm gonna do is I'm trying to remove, if I can, I'm trying to remove this spring and not lose it. Yes, here it is. Nice tiny little spring. I put it here. So Slavik says maybe just a broken cable. It could be a broken cable, but most probably not, because you can actually test here at the PCB, and here I get the same results. So if you have a broken cable, that's fine. Then you can try, it's still very finicky, try to solder some new wires here. However, I tested on these pads here, which give you the same readings, and there's still a discontinuity between black and red. So sadly, it's not just a cable, and it's a very well-known problem that the Mitsumi drives have, sadly. A better build quality is with the Chinon drives, as I said, and for the older 1541 drives, the big ones, the Alps mechanisms are much better, and there you have many more reliable read-write heads, and there's the same issue with the Mitsumi drive heads. So it seems to have been a problem with the Neutronics Mitsumi Corporation. So There's also some Loctite on these screws, and I need to take those out first, if I remember correctly. I already watched a video of someone replacing these, so I'm gonna use that as an idea how to do this. I'm gonna put the other screws over there. And now the alignment is already way off, but who cares? We'll have to realign this. I have software for that. If we are lucky. So now you can try and remove it like so. This can stay all in one place. That should be fine. Now we have the read-write head sliding freely here. We will have to reuse this metal piece, I think. This is probably the time where I should try to open this. And I've never done this before, so you can watch me succeed or fail. So I can't promise this person that this will be a successful operation, but I'm doing my best to revive this beautiful drive. So I think, yeah, this is the read-write head assembly. Looks nice, yeah, very, very nice, shiny. Brilliant. And it even has the resistor and the diode populated. I hope this doesn't pose any problems with this drive, because this drive doesn't have the tiny resistor and the diode here. I do know that the 1541-1 do have this. So yeah, we'll see. At the moment, I suppose this will just work like that. A lot of Loctite on these screws, so very carefully removing them. I'm gonna take this whole little assembly, put it over to the side, and the same on the other side. So, if anyone is joining late, there's Schweinkraft Let's Play. Hi there, just having a quick peek. Yeah, welcome. You can also stay longer. Currently trying not to destroy this nice floppy drive. And I think we can now remove the whole, oh, yeah, almost be able to remove the whole assembly, except that I forgot the screw in this wheel here, and the whole Loctite comes off as well. So there's a very tiny screw for that, putting it over here. Yeah. And then the rails come off. I think we can clean those. And there's one more issue now. I put the rails over to the side. There's one more issue. We have to recycle this metal strip, and there is some Loctite on here as well. So I'm gonna try and remove this very carefully. I might take my X-Acto knife, and I'm putting the drive a little bit to the side over here. Having one more sip. Taking an X-Acto knife, I'm gonna try to get in between the plastic and the metal. I mean, destroying the head will not be an issue because it's already dead. But I don't want to destroy this metal strip. We need that. The question is, how do I get this off of here? Well, here you can also see that the felt pad is a little bit worn, but still pretty okay, I think. I'm gonna try to scrape this away, maybe that will work. I think this might be the most tedious thing we have to do today. Maybe we can, the hole is actually bigger in the metal than on the plastic. So maybe I can cut this. That's a bit tedious. So yeah, questions of course, why do you do this? And I do quite like floppy disk drives. I mean, I have tons of vinyl records and stuff like that. I do like physical media, and I do like the sound and the handling of 5¼ inch floppy disks. I wish they would still be made, at least in low volume, and the drives as well, but they aren't. So here we are trying to repair 35-year-old or even older disk drives. Of course, the media are getting worse every year as well, and no new ones are being produced. So at some point there will be an end to all of this, but in the meantime I'm having fun working on this stuff. Yeah, the read-write head actually looks pretty interesting. It's very shiny. Has to be, I guess, because it has to glide over the disk surface without destroying it. So there's not a lot of space here. They really tied this down. I think, yeah, now I got it. Now I broke the Loctite. I need to buy some of this stuff. Here we go. Perfect. So this is the old read-write head. Close up. There's a little bit of dirt on there, but I tried cleaning it as well. And yeah, inside of this, behind the white ceramics, there's the potted coil basically. And it has multiple tabs, as I said, at each end and in the middle, I think. Yeah, this is what this whole thing looks like. And it rides on the rail to the left and here to the right. We can also clean that at some point. So that's the old broken one. I'm putting it very far away so we don't get confused. And what we need to do is we need to get this on here, and at some point also have it glued in place basically. But yeah, let's see if it's okay if it just rides like this. Not quite sure. The drive itself looks pretty clean. There's a little bit of dirt here in this middle section, which is the flywheel. And welcome to all the latecomers. We are fixing a 1541-2 Commodore 64 disk drive, which is famous for having bad quality read-write heads. Bad quality, well, they lasted for like at least 20 years, so I think that's pretty okay. But there are brands which lasted longer, and that's what counts today. But we have a replacement drive head here. I'm gonna check how to install it. So it has to go something like this. Then we can take the rails. She looks pretty clean, but still I might clean it off later and lubricate it maybe with a little bit of lithium grease. Let's see. Yeah, it's feels a bit sticky when putting it in place here. Okay, I wonder if this was all manually assembled back at the Neutronics or Commodore factory. Okay, we have the metal sheet around here. The screw needs to be put in place as well. I think I can do that already. I think it was this small one. Now we'll eventually have to glue everything into place. But for the moment, I'm gonna work like so. Not gonna tighten it super tight. I think I'm gonna have to screw everything into place now. It's actually not rocket science, this whole thing. And I wonder if someone could build this today. The most complex thing is definitely the read-write head, because it's so tiny. But everything else here is, yeah, just pure mechanics. Tightening it a little bit, not too much. The calibration will be a lot of fun, and we'll see that happening as well. I need to fetch a C64 for that, and we have a diagnostic cartridge to help us with that. Was it actually a good idea to not install this first? I'm not super convinced. I will be very, very careful here. So I think this belongs like this. Yeah, exactly. Yeah, this clamps down like that. Now we need the last two screws. I think this might actually be a faster procedure than I thought it would be. That would be neat. I was really not sure how hard this is, but I think this is not half as bad as I thought it would be. I think it might make sense to close down this thing, because it needs to fit perfectly when closed. So the screws are, as usual, of pretty bad quality. So we need to be very careful not to destroy them. I mean, my hope would be that this is the last time anyone replaces this drive's read-write head, more or less. Right. So, let's take a breath. And YouTube says there will be advertisements, right? No. So, sorry about the advertisements. Yeah. If you use ad blockers, feel free to do that. You can, of course, support me via the membership here on YouTube or Patreon, or just say, screw it. That's all good. Yeah, here we are. I think I will try to insert the spring back into this equation. Might be a tad bit difficult, but not impossible. Yeah. Catriona is here. Hello, Catriona. Now I'm going crazy. I think I need a second pair of something. Yeah, here we have some other. Inserts. I'm trying to reinsert the spring, which is harder than I thought. The head is already swapped for those joining late, but the fun of calibration and things is still before us. God, is this horrible? Nope, can't do it. This is so fucking annoying. Sorry. The problem is, I need to keep this in place, this wheel. Maybe I need to do it like that. Need to keep this in place, also bend this around. And we got it in! Hooray! Yeah. Doesn't seem too bad. So this is absolutely not calibrated yet. This will be fun. Gonna tighten the screw now a little bit more, now that the belt is in. And take a very, very short break. And I think we can already reassemble this thing. I wonder where I put the plastic bit. Oh, here it is. There's also all the screws that are missing. So I need to have this here. But I think I'm not gonna fully assemble it because we need to do the calibration. And the calibration is real fun. Carino says, I don't even dream of calibrating disk drives and I have about 50 to try it with. The calibration of 1541 drives is actually pretty simple as long as you have a good floppy disk that was written on a calibrated drive. Because what you're basically just doing is loosen up these two screws here and wiggling the stepper motor back and forth you have a little bit of leeway. You can see here there's a bit of space. We'll get a little bit back and forth until you have perfect alignment with the tracks, because shifting around this basically moves the head assembly a little bit around, and that's the whole magic basically. And we have a program for that on this cartridge which will help us do exactly that. So yeah, for these drives it's relatively easy. It doesn't have to be perfect, it just needs to be good enough basically. So I think this belongs here. I hope this belongs here, and then there's our new read-write head, which goes on like so, and this should be it, I think. I think this is good. And I think what we can do now is actually try things out. Katrina says, well, I do have all kinds of drives, only two 1541s. You can never have enough 1541s. That's for sure. They are lovely drives, super slow in their original form. I'm gonna use this so I can move this more easily. I'm gonna learn by trying and failing. That's how we all learn. And I'm not yet convinced that this will be successful, but I'm hopeful. I didn't test the head yet, so maybe we should do that first. Forgot to do that. So let's take this. It should be okay, because I sold it from a commercial seller who has a bunch of them, getting less by the minute. And yeah, most importantly, we will measure black versus red. And there we have it, 11.9 ohms. That's exactly what we need. Black versus yellow. If I can get the probe in there. Come on. Slightly annoying. 14.2, that's good. And the last, black versus blue, 13.1, yeah. This head seems to be good. Now we'll find out if it actually is. We need a couple of things. First of all, we need a Commodore 64, and we need more space. I need to see where I can put everything. I think I'm gonna clean up a bit by removing the mat. I'll leave a zip tie here as a reminder that we need to tie down the read head. I'm gonna put it here so that you can see it, I think. But I might move the whole camera over here so I get some space for the C64. So C64 goes here. Then we need an IEC cable, which I have here on my other 1541. plugs in right here. We go over here and we plug it into the C64 like so. There should be, but there isn't, a cable, video cable. This is the video cable coming up. Video cable. You will also see the video feed in a minute. I'm going into my converter box, which is plugged in. That's good. We might even get sound, perhaps. Put to S video, that's good. Furthermore, we need a power supply, a modern one, that doesn't fry our machine, because that's what some of the older Commodore power supplies do when they are more than 30 years old. Then we need to plug this in here. All right. We need to have the C64 capture, which is covered up. Which doesn't work at the moment. Let me quickly check my capture setup. Oh yeah, that does make sense. So that's something I didn't test before the stream. All right, let me quickly check if it's under here. It is not. Here it is. Here it is. Let's switch. Let's switch the C64 on. And yeah, okay. It's a bit wonky, but I'm gonna put it up here. C64 is up and running. Disk drive is here. Powering on. Still turning. That's good, and we need a bunch of disks. So, which disk can I put up as an offering to this disk drive? Let's use this one and see if it will do anything on its own. File not found. Okay, that's okay. We can work with that. That means that this is probably not yet calibrated correctly. So we're gonna go into the 1541 diag. We'll run an alignment check, and okay, this is a bit off. But not terribly so. So track 1 is actually reading nothing. Track 2 is reading track 1, so we are basically off by one track. Yeah, that could be better. But we're getting something. we're basically off by one track. So let me explain how this works. This program tries to read the diskette. The first column shows you the track number, which goes from 1 to 35 on the Commodore 1541, because that's how many tracks there are. Although disks like this should actually support up to 40 tracks, which would be normal on a PC, for example. The second column is which track was actually being read. So this is where you see the off by one, everything being read except for the first track. The third column shows you how much of the track could be read. It should be 100 always. And the fourth column shows you how much of a track was being read when you do half steps, like being in between two tracks. That should actually be 0. But the actual number that you see there doesn't matter much. What we're gonna do now is we are gonna try to put this somehow that I can reach the stepper motor at the bottom, and where I can, I'm gonna turn this off so I don't short anything, where I can twist the stepper motor after loosening some of the screws, and keep this thing running in a loop, this program up here, until we get the correct track number and 100%, basically. I'm gonna try with another disk, because this was one written in one of my disk drives, and I don't fully trust this, so I'm gonna pick a commercial disk from the German Commodore 64 magazine 64er, 64er something. And we're gonna try another round of these things. Would help if I had turned on the disk drive. So, trying again. Same issue here. So, yeah. There's definitely a off by one. So, no need to try any further. So, my own disk seems to have been pretty good. So yeah, that will be fun, because this will be like a balancing act. The cables, as you can see, are not very long. Okay, yeah. I should probably also turn this thing around so we can, at least I can see the drive LEDs. That would be massively helpful. Not drinking alcohol here, so don't drink alcohol and repair disk drives. Something different with programming that might work better, but this is probably not a good idea. Handling the disk drive with a drunken mind. Yeah, let's see how I can balance this stupid thing and adjust it without shorting anything. That's gonna be fun. And where did I put my screwdriver? Here. K-copy is here. Hello. And I think that's your drive, isn't it? I think K-copy is the actual owner of this drive, if I remember correctly. Yeah, I think I'm gonna unplug this once more, because the cables are so short. Oh. And I'm gonna pick a different screwdriver. Oh, he sent me a Commodore floppy, don't know what type. Okay, good. Then it's not your disk drive that we're repairing here. Okay, cool. But if you send me a drive, then it's definitely either repaired or it was so broken that I used it for spares. Either way, thank you. So there's again a lot of Loctite here, but now it's loosey. And I hope that we have enough leeway to align it so that we can reach track 1 and the rest. There's also a lot of Loctite here in this corner, so I'm gonna scrape this off if possible. Because I can't. Now I can turn it. Yeah. Now it's free. Now you can see I can wiggle this back and forth, and this is exactly what we're gonna do. I'm gonna start off in the extreme position that they had it fixed in, and I'm gonna try and move it ever so slightly back and forth until we have something sensible. So this is not possible to do incorrectly, and I want something to put down here so that I don't short anything out. And what can I take for that? I have some cardboard or something. Yeah, I have something that I can put on here so I can rest the disk drive on here. Ahmed Gamer is here. Hello, welcome. If you're joining late, the head has already been transplanted. Now we're in the process of doing the alignment for the disk drive, which works by wiggling the stepper motor back and forth until it works. We're doing a loop now, and nothing happens. Something is wrong. What did I do wrong? That's not good. It spins when turning on. Yeah. Alignment check. Loop. Ah, now it works. Ah, look at that. $7.99. Okay. This is looking actually rather decent. Not quite, not quite. Now I'm again off by 1. Oh, now I'm off by 3. By 2. By 1. Sparky for Insano is saying, what are you fixing? I'm doing the head alignment on this floppy drive. We are off by 1 track still. This looks better. Yeah, this is not super great. However, I think I still am gonna try this out. It's not perfect. We will do some fine calibration in a minute. And I crashed the C64, it seems. That's better. Let's see if we can read the directory. Directory is performances, speed check, reverse knock, head exerciser. We might also do that. Directory is just D. At least that works. That's a success. The alignment check is not perfect, but we've got a working read-write head. I think that's already kind of successful, and we're only 1 hour in. That's pretty neat. Ahmed, yes, of course it's a floppy disk drive for the C64. It's the venerable Commodore 1541-2. And for those who are joining late, this one is a 1541-2 with a Mitsumi mechanism. Mitsumi, you still know them from keyboard switches. They do CD-ROM, DVD, Blu-ray drives or stuff like that. Optical drives. Perhaps they also do other stuff, I don't know. But they have been around for like at least 40 years or something around that. And they used to produce a lot of floppy drive mechanisms for Commodore. And back in the day, they were cheap enough and reliable enough that they worked fine. But especially the Mitsumi branded ones have failing read-write heads, which is this little plastic piece here with this ceramic thing in the middle. And below the ceramic thing here, the white ceramic thing, is a read-write coil, which is below this PCB here, and that breaks over time, over the decades. There were other vendors like Chinon and Alps, which made better quality ones that are still alive today, mostly. But it's something that all floppy disk drives can have at some point, these failing read-write heads. And I got a spanking new one, new old stock. They haven't been in production for at least 25 years, probably longer. So there are some people who have still a little bit of stock left from back in the days. And this will also eventually fail, but hopefully the owner of this drive will have a couple of years of fun with this thing. So what we see here is already pretty nice. It seems to be working, but let's do the alignment check one more time in the horizontal position. And we do have heavy misalignment again. It now is off by 2 tracks, which is not good. So yeah, we need to continue doing our alignment. The question is there anything else that might be shifting around? This is, I think, pretty tight. And I'm wondering if this metal strip here might be an issue, if it's rocking back and forth, for example. That would be something of an issue as well. I could imagine. Sparky says, this PC I'm using has a Mitsumi 3.5 inch floppy drive. It uses a Core 2 Quad CPU. Yeah, exactly. They were, of course, also producing a lot of PC floppy disk drives. They were not known especially for quality, but they were always relatively affordable, let's say. reset. Thank you. And the disk drive motor is not resetting. So what I'm thinking is, what if I'm running the head exerciser a little bit, like so. Let's do the motor on, and I can manually step. You will see that over here, over to that side, the disk head moves. We can bump to track 0. We can go to track 4 or track 18 or 35. 35 is the last one. And we can try and see if this moves in a sensible fashion, and that actually seems to be working quite fine. This head bumping is actually very famous for the Commodore 64 because they were cheaping out everywhere. Usually your disk drives have a track 0 sensor, so that when the stepper motor drives back and the head assembly runs into track 0, there's a little switch that tells the disk drive, stop, this is track 0, you can't go further. Commodore didn't do that, they left it out because it saved 5 cents or something. So the Commodore disk drives will always bump their head like drrr, to be sure that they are actually on track 0, because they don't know on which track they are the first time you put a diskette in. Yeah, awesome, and also very noisy. So I'm wondering if there is, let me see. Actually, it doesn't look like there's a lot of leeway here. I think I will put some conformal coating on there and cure it with UV, but I don't think that it's especially wiggly in this respect. So I think we still need to do more twisting of the stepper motor, or check if we can do anything else here. But I think twisting the head, the stepper motor will be the way to go. Ahmed Gamer says the drive is doing the exact same thing as the Apple II drive. Exactly, because the Apple II drive has the exact same problem. It doesn't have a track 0 sensor for cost reasons. The Apple II drives are even cheaper because they don't have all the computing power that the 1541 has. As I mentioned before, the 1541 is basically the same as a VIC-20 or a PET or a C64. It has almost the same chips, has less RAM, has the same CPU in there. There's a full CPU in there, RAM, ROM, and 2 VIA chips, 6522. If there are any ones with the switch, I'm sure it could be. I don't know if there is a switch in this one. I don't think so. I wouldn't know which might trigger it, or if it's in the stepper motor. Not sure. The 1541-2 doesn't do the head bump as much as the 1541-1, if there's a -1. The previous version was very noisy. This here, when I use it, is very quiet. So I doubt that it has the track 0 sensor. It might just be a bit more clever, has maybe a better ROM, that it first reads whatever is there, and each track has the track number on there. So if it sees, oh, I'm on track 35, so I'm gonna do 35 steps backward to get to track 0, or to track 18, where I think the file table, the BAM, is on the Commodore disks, which is basically the same as the FAT on MS-DOS machines. I think similar, at least. So we're just gonna start wiggling again. I'm gonna put my piece of cardboard here, and we're gonna hope for the best, I would say. If I managed to actually do that. Yeah, now it's very loosey. PC 1.44 inch. You mean the 1.44 megabyte 3.5 inch? Yeah, ones have usually an infrared sensor for that. Most probably same with the Amiga drives. Those don't have that anymore. This cheapness. So. Now we don't read anything. That's terrible. Now we broke something. And I'm not quite sure what. Trying it again. Come on, I made it worse. Why did I make it worse? We don't get any response right now. So I'm gonna abort. Abort, abort, abort. What did I do wrong? Now there's something iffy. What did we change? Aha! The head pressure is wrong. Alright. Didn't break the head, but for some reason, motor off. For some reason the head pressure is wrong now. Where can I fix that? Something here. It's already sounded a little bit off. What did we change? What did happen? Sorry for putting my head in there, but I think that is good. So how does this mechanism work? This pushes down and clamps down basically this whole thing. Yeah. As soon as I push down, I get data. And when I take my fingers off, it's gone. Well, another disk? I don't think so, because I think this is really the head pressure. This clamps down and should be good enough, I think. Question is this tight? Yeah, this is tight, very tight. This seems to be good. We were so close. I might take another disc, yes. Anyway. Oh, it was already on. No, same problem. As soon as I press down a little bit, not on this part obviously, because that's not moving. Now it also sounds better. Yeah, this would be actually a pretty good alignment. I would leave it like that. But not like this. Annoying. So it's not the disc, but still a little bit annoying. How can we increase the head pressure very, very slightly? That's the question here. Because the head is actually running on the rail and the rail is fixed in place. So I don't think that's actually very much possible. Only thing that increases the pressure a little bit is this top part. What can increase the head pressure is this little itty bitty thing here, because, or is it? No, it can't. But this thing here, if I push this down, this is actually what pushes the whole assembly down, like this, like so. So if this is actually a little bit bent or something, it will be, but it's pretty thick metal. Interesting. There is some tape on here. I wonder if they use tape to increase the head pressure, basically by lifting this thing a little bit up, so that the lever here pushes down harder. Maybe that is the case. I'm gonna keep this. There's a spot where this like this latches in, and when I turn this not quite as much, there will be increased head pressure. I see the head assembly moving up a little bit afterwards. So I'm gonna open it very slightly just to see if this makes a difference. No, not quite. I do hear the drive sound being a little bit different. And now, if I press down here, it's fine. Yeah, so as a quick fix, I would simply put some Captain tape on here. Probably. Otherwise, I would need to bend the metal, but that's a bit more destructive, I think. Oh, there it read some kind of garbage. I think the head pressure is not as perfect as it should be. Yeah. So this whole assembly needs to get lowered a little bit further. So I'm gonna try to put some Captain tape on it. I think that's perhaps the way to go, because that's reversible. pretty much. Katrina says sandpapering 0.5 millimeter of the slat left and right where the notches for the head right back and forth. And that will be very destructive. That I can't undo as easily. Like here, this thing. Probably wouldn't want to do that, especially since this is not my drive. So I'm gonna try the Captain tape. Count Netzrak is joining. Hello. We already exchanged the read-write have if you were hoping to see that. But feel free to rewatch the stream. Now we're trying to calibrate it, and it seems that the head assembly is not low enough or doesn't put enough pressure onto the disc. Well, the pressure is only done by the this top piece here with the felt pad, and I need to press down a little bit, which is a bit annoying. So I'm gonna take my X-Acto knife and cut off one more piece. Hopefully. Probably not. Let's do it like this. So the problem here is that I really have no clue why this is the case and why we didn't have that before. I think I didn't bend this thing in any way that was harmful. But, well, let's see. So I've got now 2 layers of Captain tape on here. Let's see if this is already enough. No. I think this definitely needs to have much more pressure, yeah. Also getting faster. Obviously because it doesn't have any arrows. There was also an issue with the last 5 tracks, which are often very... I mean, they are the innermost tracks with the highest bit density and might be more unreliable anyway. Okay, cool. That did work. So we are almost there. Question is, what can I do? What I can do is I can bend this top part a little bit, very, very carefully. Because that might be the issue. I'm gonna remove the Captain tape because I think that's way too thin. This won't help. At least it didn't make a difference here. Question is, can we actually bend this, or that's very annoying. You're still on? No. Doesn't help. Doesn't help, doesn't help, doesn't help. Head exerciser, shift. No, that was complete bogus. Head exerciser F7. So this part is very, very stiff metal. I think the best way for me is to actually bend that other thing, which I'm a bit afraid to do. However, I can remove this bar here to move this out of the way. And then I can gently, very, very gently, try to bend this up a little. This is a bit slippery, I must say. Okay, once more. Ahmed says, there is a problem with the thing that when you turn the handle it closes on the disk. I think this is from the wrong movement of the handle, not the movement from the user. Yeah, basically, yeah, the whole latching mechanism here, this part, there's some problem. There we go. This is good. The problem is now that the in-between tracks are off. But to be honest, this is a good result. If the fourth column isn't yellow or green, that's something I would be willing to live with. Because I tried fixing the same issue on one of my other drives and I couldn't get it to work better. And the drive works just fine. The main reason here is to get the third column to 100. Ahmed says the 8-bit guy uses lithium grease. Yeah, I do have lithium grease. We can try to make things a little bit more slippery. Not sure if we actually need that. I think this did the trick. I bent this. I'm gonna show you this part here. I bent a little bit by taking out this rod. So I could lift this whole arm a little bit further up, and then I could use this metal brace here as a leverage, and just with my, like, you can still see the indentation on my thumb, just use my thumb as a lever to basically do that. I want to try this out. I want to see if this actually runs a demo now, because then it's good enough, I would suggest. The screen is a bit squashed. Can I fix this? Can I select that screen here somehow and make it a bit, yeah, not quite. Let's see, where's the transformation in OBS? So you get the best possible quality. Let's see, position size. Yeah, this should be, let's just put a 600 in here. 620, 40. I think this is pretty close to 4:3 ratio. So let's, oh, that was garbage. Load. That's better than before, I would say. We won't have any sound because that is not hooked up. Let's see if I can hook it up very quickly. Yeah, I think I can. Just give me 1 second. with intermittent video. I need the USB cable from my mixer, and that's here, because I guess you want to hear some music. So where is... Ah, now it's here. Okay, there should be some buzzing already. It's working. Turn down the music a little bit. Okay, yeah, you're hearing the sound. I just checked on the live stream. Let's have a look if the demo works. This is RGB by Offense, Fairlight and ProSonics from 10 years ago already. Man, time flies by. Will it work? Does it hang? I think it's hanging, isn't it? I think it's hanging. It's... Oh, we're so close. We're so freaking close. This might be pushing it too hard. Dang it. Oh no! Here it is. It's working. Just took some time to load. I need to turn up the music a little bit so that you hopefully don't hear too much of it double. But I need some audible feedback. Yeah, this is neat. Gonna turn down the music a little bit. The demo scene on the C64 is immensely active. This one is 10 years old, but there's like dozens of demos appearing every year. Ah, for chorus here. Hi, you missed main stuff, perhaps. I'm not sure since when you were here. For everyone who is joining late, we are repairing or have almost repaired completely a Mitsumi based 1541-2. It had a dead drive head, this thing here. There's a white ceramic thing which houses the read-write coil, and there's a break between the ground and the red wire. And I've got a new old stock one and replaced it, and we did some alignment, some bending of metal, and now it's working more or less again. And we're watching the demo RGB by Offense, Fairlight and ProSonics from 10 years ago. And I'm always impressed what the C64 can actually do. It's the color palette is obviously limited, but stuff like this was so hard to do on a 1990s PC, like a 386 or even 46 sometimes, with the scrolling and the sprites and so on. That's where the C64's big chip actually shines. Yeah, and I think people really get the most out of this little itty-bitty machine. 40 years on, yeah, 40 years after its inception. That's so crazy. But I would say running a demo with its fast loading capabilities successfully, I would say this is a successful fix. What I want to do, probably not on the stream, which I will close in like 15 minutes or so, is to lock all the screws in place with some conformal coating, because I don't have any Loctite, and cure this with UV. And that should keep it stable so that I can ship it back to its original owner, so that he might have a lot of fun with it. running games or demos and stuff. And I think this is as good as it gets with this repair. It was easier than I thought, so the whole replacing the head is actually not that hard once you've seen it. The alignment process was a little bit tricky, and I was very stumped when the head pressure wasn't quite correct. Wonder how that happened, but yeah. Oh, it says flip disk. Let's do that. Side B, basically. And if this demo runs to completion, I would say this is pretty much a success. Now it figured out that there's a new disk inside. Yeah, and stuff like this 3D twisting scroller, I think that's pretty neat. This would be very CPU intensive if you want to try this on a 386 or something. Something similar was done by Future Crew in the Panic intro, but on my old 486 SX this would lead to slowdowns while 3 of these scrollers went across the screen. That was like crazy. And that was like a CPU that was nominally at least 25 times faster, and of course the 46 has so much more capabilities than the 6502. So yeah, the SID chip and the VIC chip definitely helped the C64 to do all this crazy stuff. Yeah, I think this is visually and also music-wise very pleasing. I love the C64 demo scene. It's really impressive what they're doing. And I'm very happy that the drive works again. And as I said, I wish people would still manufacture these itty-bitty things. But yeah, it's not the time for floppy disks anymore, sadly. But it's so cool to be able to still repair a couple of those and maybe have them last 10 more years or something. So we can have stuff like this running from a real floppy disk. Which incidentally is actually relatively high capacity, even though it's only using 35 of the 40 tracks. There are special formats that use 40 tracks, but they're non-standard, that go up to I think 190 kilobytes per disk side, which is a little bit more than the IBM PC or XT used. They had like 180 per disk side. Yeah. So there are a couple of games and a couple of demos that use that, but it's always a bit tricky on the inner tracks because the Commodore drives were not known to be very reliable. I think you're good at fixing drives, Ahmed says. Well, this was my first try. I'm at least with head replacements. I did fix drives by replacing broken ROMs or identifying broken capacitor or something like that. Sometimes replacing the whole mechanism because it was junk, stuff like that. And I replaced a couple of voltage regulators. That is what I can do, more or less. I'm still very eager to see this guy who rewound the coil do more crazy stuff like that, because that would actually help a lot, because then you can actually revive these heads that have gone bad. But I see this only happening at a very low scale, like hand manufactured, and probably only a couple per year you could do like that, because there's nobody has any mechanized tools for doing that yet. But you never know what the crazy people of the retro community will do. So yeah, I will definitely save this. Who knows? At least for showing people what these things look like. Even though I probably will never wind my own read-write coil. That would be crazy, I think. Yeah. Are there any more questions, comments? Did you have a C64? Did you own a floppy drive? Did you only have the dataset because floppies were too expensive? Were you born after the era of the floppy disk, which is also always a possibility nowadays? Things like that. Because I think I have like 5 to 10 more minutes until we'll close up this stream. But I really like this drive. It's great. It's working now. And the demo is also very neat. Also, very important to know, the C64 palette has only 16 colors and there's no fading of colors. Stuff like you're seeing now is simulated by flashing the colors very quickly and cycling them basically in their apparent brightness. Yeah, so this is... Flip the disk. There's another side. Okay. Do I have it here? Or will it be a sad demo? Because I don't have the disk here. No, I actually have. There's a third side. The third side there is. Let's see if that also works. And if we can get through a 3-side demo, I think we're really good to go. Pretty neat. Yeah, looking good. Is there still sound? Yeah, it is. And you can even date this demo by looking at the smartphone there depicting. That's 10 years ago. Okay, there's some birthday wishes. Very nice. Sometimes the demos also use the activity light and flash. Yeah, here it is as well. You see it's actually fading on and off. Usually it just goes on and off immediately. But there's some loaders that fade in and out the activity light like this. And that's pretty neat. That's totally useless, but they still do it. I mean, it's I love it. Such a useless effect. There was also like last year or something a demo that 2 years ago that ran on the floppy drive itself. You cut the serial cable this here and attach a composite cable on there, and the CPU, the 6502 in there, would bit bang the composite signal, and that's so crazy because, as I said, this is basically a 6502 based computer. Computing power is the same as in the C64, only with less RAM, comparable to the VIC-20 or the PET, because basically what Commodore did with the whole line is just stuff more custom chips in there. The VIC-20 and the C64 basically just shrunk down Commodore PET computers with the same interface chips and the same CPU and the same amount of RAM, basically. Roughly speaking, there's of course some slight differences, but yeah, that's how it is. Okay, I think this will be the end of the demo. Almost. Yeah. But I think we can say that this is working just fine. I will probably put the zip tie like this here. Something like that. Not gonna touch it while it's running. Not gonna jinx it. This is also pretty impressive. Tons of scrolling text. Not sure how they do it. Sprite multiplexing or char-set manipulation, I don't know. It's always sometimes very impressive how they break the hardware restrictions of the C64. Maybe it's a combination of both. This is a slightly weird looking Princess Leia. But the face looks weird. Yeah, this is the end of the demo. Cool! I'd say it's a success. Ahmed says, is the 1541-2 drive a good or a bad drive? The 1541-2 is definitely not a bad drive. If you can get your hands on it, try to get one with the Chinon drive. You can recognize it because the Mitsumi drives have the bezel which is slanted here, and the do I have one here? I think I have one here. No, not here. Where did I put it? Where did I put it? Let me check. Is this the... No, this is the Chinon drive, I think. Yeah. So there's a slant here in this bezel, and on the Chinon drives it's actually straight. Try to get one of these with the straight edge, because here you will have almost guaranteed a good drive head. Whereas the Mitsumi drives have this issue that there might be a bad drive head, and it's, as you can see, a bit difficult to replace because you have to find a newer stock drive head, which can be a problem. The disadvantage, I think, is that you definitely need a power supply, probably a modern replacement one, because it doesn't have an internal one. It's of course much smaller and runs much cooler than the previous 1541-1, or doesn't have actually the one. But some people like the looks of the original one better because it fits the look of their C64 bread bin. This here is actually designed for the C64-2 or C, depending on what you want to call it. Yeah, it's a bit, yeah, whatever you like best. It's definitely more highly integrated. The 1541 usually has a larger PCB, but there are different revisions. So, other than that, all the 1541s are compatible to each other. None is faster or anything. What was that? Will there be something? No, I don't think so. So there's no drawback. You can play the same games on a 1541 and on a 1541-2. So if you can get your hands on one, you might want to take it. But if you get one with the Mitsumi drives, you know that there might be issues. But now you know how to replace it and how to align it, more or less. How to do maintenance on it. Yeah, I think that's enough for today, right? Thank you all very much for joining. It was really a wild ride. I'm gonna shut down the stream now. You can watch some more videos on floppy repair, C64 stuff, and many other topics on my channel if you want to. Yeah, this is basically almost good to go. I just need to fix the screws into place so that it doesn't misalign during transport when shipping back to its owner. And I have to put the zip tie on here so that the cable doesn't flap around too much. But it needs to have enough leeway to be able to move freely around. Okay, that's it. Thank you very much. Share, like, subscribe, all the usual crap. But I'm already very happy that you all joined. There was great attendance, great chat. And see you soon, I hope. Bye.